Welcome to EDU World Space.
Okay, in this problem, we'll be looking at how to find the arc length of a vector space, or a vector in space. So just recall that the formula to do that, the way we do that is by finding the integral from our upper and lower bounds of the magnitude of the derivative of that vector, or another way to say that is the square root of the sum of the squares of the derivatives of the component of that vector. So it sounds complicated, but once you see it in action, it's not too bad. So what we'll go ahead and do with this problem, this is the vector we want to find the arc length of between 0 and 1. So we'll go ahead and start evaluating this. We know that this arc length from 0 to 1 is going to be the square root of the sum of the squares of the derivatives of each component. Okay, so our first component is 1. There's nothing written there, so it's 1. The derivative of 1 is 0, and 0 squared is 0. So we really have a 0 there. Here, the derivative of t squared is 2t. We're going to square the derivative. So we get 2t squared. And the derivative of t cubed is 3t squared. So we'll square that. And of course, we're finding this integral with respect to t. Okay, so we'll go ahead and start simplifying and evaluating this integral. Okay, so 0 squared is 0. 2t squared is 4t squared. The square of 3t squared is 9t to the fourth. Okay, so now we want to try to simplify this. This isn't exactly easy to integrate as it's written, but we can do some factoring and make it a little bit more bearable. I can factor out a t squared from both terms. So I'm left with 4 plus 9t squared. And the square root of t squared is t, so I can just pull that guy out of my radical. 4 plus 9t squared. There we go. And why is this nice? Because now I can do some u substitution. I know that if I let u equal 4 plus 9t squared, then du is going to be equal to 18t dt. The derivative of 9t squared is 18t, derivative of 4 is 0. And so du over 18 is equal to t dt. And why is that nice? Because I have a t dt in my integral right now. I don't want to forget to substitute my bounds. Right? If I'm doing u substitution, I need to make sure I substitute those. So when I plug in 0 for t here, I get a lower bound of 4 plus 0, so a lower bound of 4. When I plug in 1, I get 4 plus 9, so an upper bound of 13. So now I'll complete my u substitution. I have this 1/18 I can just pull to the outside of my integral. My new bounds are now 4 and 13. Remember, I replaced 4 plus 9t squared with u. And just to make it simpler, I'm just going to write it as u to the 1/2 instead of square root of u. And then t dt is now my du. It was du over 18, but I already worried about that 18. So this should say 13. Sorry about that. All right, and so now I can go ahead and evaluate this integral. This is equal to 1/18. Okay, u to the 1/2, I will add 1 to my power. That will make it 3/2. And of course, I'll divide by 3/2, which is the same as multiplying by 2/3. And I'm evaluating this from 4 to 13. Before I do that, I'm just going to simplify my fractions, 1/18 and 2/3. That's the same as 1/27. So I have 1/27 u to the 3/2. I'm evaluating that from 4 to 13. So now I will plug in and I have 1/27 times 13 to the 3/2 minus 4 to the 3/2. And I'm fine with that answer as it is. This is an acceptable answer. You could also, 13 to the 3/2 isn't so easy to evaluate, but 4 to the 3/2 is a little bit easier. So if you want to, you could take it one step further. 4 to the 3/2, of course, that's the same as 8. And there we have it. We have two forms of our answer. And that is how you find the arc length.